Come, let's see about a very special type of binary tree which is known as the binary search tree. In this video, we'll look into how to create a binary search tree if we are given a list of elements. And then in the following videos, you will see about how to insert an element into an already existing binary search tree, how to delete an element from a binary search tree, and the related time complexities.
In this lecture, we are going to see a special type of binary tree which is known as a binary search tree. So the rules associated with the binary search tree are, the first rule says that it must be necessarily a binary tree. So what are the rules of binary trees? What is the rule for a tree to be called a binary tree? That every node must have 0, 1 or 2 child nodes. Number of child nodes cannot be more than 2 for any node in a binary tree. So this rule must be followed. The second rule says only unique keys are allowed. That means the elements must not be duplicate to each other. Repetition of elements, repetition of keys or repetition of the value of the nodes is not allowed. The third rule states that the value of the left child must always be less than the value of root node, which must be always less than the value of the right child. This is one of the most important, I would say this is the most important property of the binary search tree. So now let's consider this given list of elements, and now the question is that we want to create a binary search tree using this given list of elements. So step 1 is to consider the first element as the root node. So let's make this as the root node. Then we consider the next element. It is 39. So we perform a comparison and we check if the key value is less than the root node value, then go to left, else go to right. We will follow this for every key that we want to enter. So as we come here, we check 39 with 45 and we find out that 39 is less than 45. So we go to the left, there is no other node, so we make it the left child of 45. Our next element is 56. So same, we come here, we check and we find out that 56 is greater than 45. So we go to the right of 45 and there is no right child. So we simply make 56 as the right child of root node 45. We take the next element and we perform a similar check with the root node 45, and we find that the key to be inserted is, the value is less than the root node. So we go to the left subtree of the root node. There we go to the next root value and we again check it. Since 12 is less than 39, therefore we insert 12 as the, so we'll insert 12 as the left child of 39. Then we'll see the next key element, which is 34. So we again start checking it from the root. So 34 is smaller than 45, so go to left. Now 34 is smaller than 39, so it should be at the left side of 39. But when we come here, we find out that 34 is greater than 12. So what happens here is, we insert 34 as the right child of 12. Then we look at the next element, it is 78. So we check for the root node value, it is greater than the root node. So we go to the right and it's greater than 56. So 78 becomes the right child of 56. Then we pick up the next key value, which is 32. We again start performing the check from the root node. So 32 is less than 45, so go to the left. Again 32 is less than 39, so go to the left. But 32 is now greater than 12. So here we encounter that 32 is greater than 12. So we go to the right of 12. As we go to the right of 12, we encounter node 34. But here we can see that 32 is less than 34. So if the value is less than the root value, what do? We make it as the left child of the root. So here with respect to 32, the root is 34. So we make 32 as the left child of 34. Then we pick up the next element, which is 10. So for 10, we check it with 45. It's less than 45, so go to the left. Check it with 39. It's less than 39, so we go to the left of 39. So it is here. We check. So again 10 is less than 12. So we have to go to the left. There is no other existing node. So we make 10 as the left child of 12. Clear? Now let's look at the insertion of the other element. Next element, which is 89. So for 89 also we follow the same procedure. We check it with 45, it is greater than 45, so go to right. Check it with 56, it is also greater than 56, so go to the right. It is also greater than 78, so go to the right and make it the right child of 78. Now comes the next element, which is 54. We check it with the root node, it is greater than 45, go to the right. We check it with 56. Now 54 is less than 56, so we go to the left of 56. Since there is no other node, so we can directly insert 54. Now let's insert 67, that is the next key element. So again we will perform the same steps. We will check it with the root node. 67 is greater than 45. Go to 56. 67 is greater than 56. Go to its right child. Right child is 78. So we find that the key to be inserted, which is 67, is less than 78. So we have to go to the left of 78. As we go to the left of 78, there exists no node. Therefore, we can simply insert 67. Now coming to the last element, which is 81, we will perform similar checks to see it is greater than 45, then it is greater than 56, go to the right, greater than 78, go to the right, greater than 89. Is 81 greater than 89? No. 81 is less than 89. So we go to the left of 89. There was no existing node, so we can simply insert 81 here. So if you look at these intermediate nodes, what you can see here is, say if I ask you to look at 34. So this 34 is See, since it is to the right of, it's to the left of 39, that means it is smaller than 39. But it is to the right of 12, that means it is greater than 12. So if I say 34 should be in between 39 and 12. This is the relation. So this is what exactly is happening here. Okay. So I'll show you how my final tree would look like. So the created binary search tree will look like this. Okay, I hope this thing is clear to you guys. Now next I'll tell you one more thing. Let's try to find out the in order traversal of this created binary search tree. What will be the in order traversal of this binary search tree, the created binary search tree? So what do you mean by in order traversal? That you will traverse the left first, then the root, and then the right. So let's see. We go here, we go to the left, we go to the left, we go to the left. So this is the end because this is the left leaf. So left, then coming to its root, which is 12, and then the right. As we go to the right, this is not the leaf. So first we will traverse the left. There is no right, so it's null. And then the root. So it's 34. Okay, so I'll simply write it here, the in order traversal, so that it's in a line. Okay, so the left of 39 is traversed. Is there any right of 39? No. And also the in order traversal says left, root, and then right. So the left subtree of 39 is traversed. Now we will traverse the root, which is 39. There is no right, so it's null. So the left subtree of the root node 45 is traversed. So after left, what do you have to travel in order traversal? It's the root. So we write 45 here. Then we go to the right subtree of 45. So we go to the root, but we have to travel the left. We have to travel to the left first and traverse it. So we will traverse 54. This is left. Then it's root. So 56, and then we will have to go to the right. So as we come to the right, we encounter another root. So we will not traverse this. Instead, we will go to the left of it. So it's left, then the root, which is 78, and then we are left to traverse this. So when we come here to the root, what we have to traverse first? The left node. So 81, then the root, which is 89, and then the right, which is null, so we don't have to traverse anything to the right. So can you tell me what is this? This is the sorted list of the elements, of the same elements that were used to create a binary search tree. So we can say that the in order traversal of a binary search tree will always produce a sorted list of elements in the increasing or the ascending order. I hope this thing is clear to you. So I'll just give you a quick revision of this. This was the list of elements using which we wanted to create a binary search tree. So using the elements, we created a binary search tree. The binary search tree was this. After that, we found out the in-order traversal of the same binary search tree. It will give you a sorted list of elements in the ascending order. I hope this topic is clear to you. This is one of the most important topics in data structures. It's very important to understand this thoroughly. In the next session, I'll tell you about the time complexities related to the binary search trees. Thank you.